Awesome. Okay, thank you so much, Sharik. So yeah, let me just give a quick intro. We can jump into the presentation. And yeah, so thank you so much for joining, everyone. We are at the office hours number 4 now. This is another opportunity to present the project proposal that you have. Here is the issue with the agenda. So you can see that there are some people who signed up for the previous week but couldn't make it, so they are presenting now. Starting with Sharik, and there are a bunch of people who signed up afterwards. There is many people. I believe there is maybe too many people to make it in this call. So we might need to do another one afterwards next week. But for now, please keep your presentation relatively short, 5-10 minutes, so there is enough room for everybody to present. And yeah, Sharik, please share the screen and go ahead. No need to hesitate. Um, yeah, so yeah, we have the agenda in the issue there, and yeah, um, you're starting.
Beautiful. Okay, thank you for that intro, Mario. Let's get started.
Yeah,
So,
cool.
hi guys, I'm Sharik, and I'm working on the Team Validator client, and I'm collaborating with Mark,
Hello.
who's another permissionless. Can you get what happened?
Oh,
Oh
I
yeah,
just
Mark
cut
said
off.
hello.
Sorry.
Okay. Yeah, yeah. We're mentored by Colby ML, who's one of the leads at Dream. So a little bit about us. My name is Sharik Nair. I've worked in the Web2 space for most of my experience, and I'm deeply fascinated by Ethereum. And I wanted to, and I'm more fascinated towards consensus layer clients. And Reem is one of the upcoming cleanest code, most approachable code consensus layer clients, which is why I am contributing to Reem. And I can let Mark go now.
Hi. Okay. I'm Mark. I've also done a lot of work in the Web 2 space, but I've also done quite a bit of Rust and like C++ mostly C++. So I decided to do Ream because it's one of those Rust clients. It's a new one. I thought it would be a good opportunity to like help uh, build up a new client, especially because like the whole client diversity initiative. So yeah.
Sweet. So, I believe everyone here knows a fair bit about Reem, but I can just give a quick recap. Reem is a beam chain client, but as the beam chain specs aren't released yet for various reasons, including like just familiarizing their developers as well as to promote client diversity, they are building a beacon chain client, and in accordance to that, we are creating a validator for the beacon chain client. Eventually this validator will work for the beam chain client. So we can straight up jump into what we have done so far. Uh, we started off we started off with reading through the we started off with a lot of research, reading through the all our resources are on the last screen, or we watched a couple of videos. The Ethereum study group videos were substantial in helping us grasp these concepts, as we hadn't done this before. uh, and and then we read through the consensus specs. Although the consensus specs aren't like the most comfortable read, they have a lot of information packed in it, and I recommend anyone working on a client to read through them. uh, so reading through these specs, we found that it contained a lot of helpful functions that we believe we would use in the future. And it contained a lot of structs. These structs were as simple as like, what does an attestation data look like? What does a block look like? Some of these were implemented in the Rust in the Reams code base. However, most of them were not. So we started by implementing all of the 50 helper functions across all of the honest validator specs and all the associated structs with them.
Okay. So a little bit about key stores. So currently, because a lot of the current tooling relies on a specific format, which is like EIP2335, to essentially store private keys and public keys for validation, like staking. So essentially, a key store is just like that JSON encrypted format, and it has a few ways to essentially, oh, and it has a few essential ways to get like that derived key for like actual decryption and encryption. So like script and PBKDF2, for example. So what we did here essentially, we parsed the format and we found the actual like key derivation function. We took that, processed it. We actually implemented our own script function, and there's actually good reason for that. Because the current state of the art, at least in like Rust, is actually 30% slower than what we had actually. Like we managed to actually improve it significantly compared to like the actual current like publicly available crate. So we were working on that. We made that implementation. We managed to have the results, which is like that 30% boost in terms of performance. And obviously it was important because like this tooling, the staking CLI uses this. I think there's I think a web tool as well that also uses it. So I'm trying to find out what it was, but yeah.
Sweet. We then found out that PLS signatures are used across. I mean, we knew this, but like PLS signatures are used across the consensus layer for a lot of processes. However, the Ream PLS crate did not yet implement signing or aggregation. So the Ream PLS crates uses the supranational BLST crate as well as the ZK crypto crate that is optimized for ZK VMs to manage all of its BLS functions. This includes aggregation as well as signing and a couple of other functions that I'm not able to remember at the moment. We went ahead and implemented it. We implemented signing. We made it a trait that both the supranational crate as well as the Zico crypto crate could be accessed from. Uh, so if you were importing this and you wanted it to be you didn't want this optimized for ZK VMs, you would import you would import it with the ZK crypto tag. Uh, and yeah, Mark, I went ahead and implemented signing, and Mark went ahead and implemented aggregation. Uh, Up next, now we were at a point where we can successfully start building a Beacon API client. So with a Beacon node exposes a public API called the Beacon API. This is how all communications between the validator client as well as between the validator client and the Beacon node takes place. This allows us to publish blocks. This allows us to make attestations, uh, fetch duties, about everything a validator does in relation with the Beacon node is that happens through this. So we created an HTTP client using the request crate in Rust, and the Beacon API spec, as shown in the picture here, outlines everything required for the validator. They have hundreds of other APIs, but this is everything required for the validator. So we went ahead and implemented each and every one of them as functions in our Rust code base that we would use later.
Oh, hello. So currently there's essentially two different sort of like flows for this. Like there's timer-based and event-driven validator flows. So currently there's quite a few events, like according to like the current Beacon API specs. So like reorgs, heads, blocks, things like that.
Excuse me,
Oh,
Mark, I'm going to stop you for 1 second. I think there is that because of me. Now, can you speak now?
oh, hello.
Yeah. There was echo because of me.
Sorry.
Yeah,
Sorry
continue.
about that. Anyway, so there's essentially two types of flows. Like there's a time-based and event-driven. So as you probably know, the API specs for events, there's quite a few of them. So event like heads, blocks, attestations, volunteer exits. Those. So it's a way to essentially like for the Beacon API, like the Beacon node, to communicate to the validators, in a sense, like those server-side events. So currently there's like two types. So there's a timer based. We actually did this one because it actually allows like precise timing, like right at the slot and epoch boundary, so I don't have to worry about any delays. Because if we're to do like an API call or like event driven for that sort of thing, there might be a chance that say there's like a delay because of the network. So you don't want to do that for like the actual like event, like that duty execution, because in order to do that, it's important to be like right on that boundary, like timed perfectly. But
Sweet.
event driven, it's important. It'll be useful. Like we're still working on doing like connecting some of the event driven stuff, but the plan is because we actually have some stuff done, like for actually taking in the events. But we're going to be using that to actually process reorgs. So if there's some sort of chain reorganization event, we'll be detecting that through the event API.
Sweet. Thank you, Mark. Uh, Now let's delve into what we are doing right now and what we're planning to do in the future. What we're working on right now is the main validator flow. Uh, there's a validator flow.md doc that outlines in within like 100, 150 lines how an honest validator should function. Uh, each of those lines is like 100 lines of code when translated, because it's like it'll say something like wait for a block to be proposed or wait for one third of the slot, and you would have to set up an events API, you would have to start a channel. uh, we're making significant progress with this, and once this is done, we should be able to start testing out the basic validator functions. So we have functions for on epoch, on slot if you're an aggregator, and on epoch end. I think we will have to add a few more in the future, but we'll see how that goes. So on slot we will make an attestation, on slot we'll propose, and on epoch we'll fetch duties. In terms of roadmap, we have worked on a lot of the validator foundation, everything required to build the validator flow. Now we're working on the validator flow. Eventually, we will work on testing. We have looked into it, and we'll work on it using Assertor and Kurtosis. If there are any other testing tools available for validators, please let us know. Then we want to see how we can get to deploying on testnets. I'm not fully versed with how this would work, but we'll get there. And then once all of that is done, once we are tested on a testnet, we will look into performance and UX improvements. So the goal is for us is to build a minimal viable validator client for Ream. This validator client should be able to perform all the main validator duties. It should load in a key store, check what validators are in there, activate those validators, get them to the active states, fetch their duties, propose blocks if they're a proposer, make attestation if they're a tester, aggregate attestations if you're an aggregator, handle sync committees, handle reorganizations, and handle voluntary exits, and do all of this without getting slashed on like a regular basis. Yeah. Thank you. That was our presentation. For anyone looking for further resources, this is everything that has been influential in shaping our understanding, and we will share the link to this, and you guys can and hope you guys find it useful too.
Okay, thank you very much, guys. Awesome. We got some comments in the chat, but if you guys have any questions, comments, feel free to raise your hand.
Oh, regarding the duties change on reorgs, we're actually planning to do that part. It's like I said, we're still working. Like we're still have a few things left to do, and like reorgs is one of them. So our plan is actually like reprocess the duties on that event. So we have taken consideration to that. Just have to. We're still working on specifically reorgs. That's one of the last things we really have to do before we actually get like those integration tests and like actually deploying on like the hoodie testnet, for example.
Okay, thank you, Mark. Awesome. Yeah, very well. So with this, we can move to the next presentation. Odinson, if you are ready. Hello?
Hello, am I audible?
Yeah. Yeah, it's a bit loud in there.
Okay,
Yeah, it's good. It's good.
got it. I
Go
hope my
ahead.
screen is visible and I am audible.
Yeah, all good. Yeah.
Yeah. So, hi everyone. I am Paul of Vomik, and I'll be presenting my project proposal for Lighthouse's Better State Cache Heuristics. So, a little brief introduction about me. I am Paul of Vomik. I am currently in my final year of engineering. I am based in Kolkata, India, and currently I am a permissionless fellow in EPF6. So, what I'll be talking about is the problem which led to this project like in the first place. then the current caching mechanism in Lighthouse, how it works and what is implemented right now, then the project description, like what I propose to work in this frame of 4 months for this project, and some possible challenges or like implementation technicalities, and finally some resources. So what the problem was initially. So you all have heard about the Petra Holsky incident by now. So in February this year, the Holsky testnet, it faced a severe non-finality event during which the specifically Lighthouse nodes, they experienced this extreme memory growth, in which the disk usage or the disk size, it went from around 20 GB, that is in normal conditions, to over 100 GB. This was caused because the beacon state cache, which is currently implemented in Lighthouse, it is currently count based rather than memory based. I will be talking about it in the next like page, next slide. So even though the cache was around 32 states, each state grew in size like massively, up around I guess 70 MB per state, and due to inactivity leaks and validator penalties, and because of this thing, the it led to out of memory failures and validator downtime. As I mentioned, like Holsky finite non-finite incident, what happened, and the static LRU cache limitations. So what currently is implemented in Lighthouse, that is they have a count of till 32 beacon states, but it went to out of memory condition. So how caching currently works in Lighthouse? Currently, Lighthouse uses this LRU cache implementation. What is LRU? It is the least recently used cache. So what it does is that it keeps track of the recently used or the recently justified and finalized beacon states, because those are hot right now, and those are to be reused in the future again because for the newer states, and it does not count the earlier states that was in the beginning, from the beginning. So as I said, like around 32 states would typically occupy around 500 MB. But during the stress events, or like what happened during Holsky, those 32 states exceeded over 2 to 3 GB, and that was unsustainable, especially for people or like for stakers who are solo or do not have those hardware specs which would require this heavy memory usage or disk usage. Inefficiency during non-finality. This design choice right now, it is very simple. The LRU time-based LRU cache technique is very simple, but during these conditions, that is what happened during Holsky or during non-finality conditions, it leads to out of memory. Why is that? Because for finalized data currently, the block roots are stored as a block slot to block root mapping. This is normal, like this is fine during normal conditions, but whenever it comes to non-finality conditions, the block roots are stored as a block root mapping. This is not sustainable, and
I
Odessa.
lost them. Yeah.
Yeah, me too. It's a shame. Let's give him a minute. I don't want to cut him short. Hmm. Sorry about it, everyone. Um, we got Vinit in next in the line. Are you with us?
Yeah. Hi, Mario. Should I
Okay,
start?
so yeah, while we are waiting for this, and I don't want to waste time on the call, so I guess get started. Prepare your screen and okay, awesome. Yeah, let's do yours, and we can come back to Odinson when he comes back. Yeah.
So yeah, we have decided to work on Pureit, that is EIP 7919. I'm working with Tamagana on this, and our mentors are Ethan, who is the author of the EIP, and Advait from Nimbus. Uh, So yeah, regarding Pureit is a meta EIP which contains other EIPs which are important to improve accessibility, data accessibility for Ethereum. So these EIPs are grouped into four categories. We have decided to start our work with log reform EIPs. So log reform EIPs address a lot of problems with current logging systems, which results in downloading uh, access logs, and some logs are missing. So there are a lot of problems. So these EIPs basically, uh, proposes to resolve the inconsistencies. And other category is remove all transaction type. This category basically aims to replace current RLP encoding with the SSC encoding uh, in transactions. Uh, so yeah, so these are the two categories which we will be uh, targeting for the fellowship. Okay. There are other two categories like serialization harmonization, which aims to replace JSON RPC with the binary API, and the other one is the SSD requirements, which are the dependent EIPs which are required for other EIPs which are aiming to replace RLP with SSD and the other EIP. So yeah. So yeah, let's start with the log reform EIPs. Log reform EIPs are required because there are some inconsistencies in the current logging system. Let's say some smart contract wallet wants to download uh, the logs in some block range, but what happens is uh, the wallet or client has to download a lot of access logs due to false positive nature of the Bloom filters. And another problem is because the light clients and mobile devices don't have enough resources to process a lot of data. uh, so they have to rely on the trusted JSON RPC providers like Infura or Alchemy. Uh, and it's so the current logging system is impractical for the light clients and mobile devices. Okay, so that's why log reform EIPs uh, are trying to address this. So yeah, a brief overview what happens when logs are generated. So whenever some smart contract does some ERC20 token transaction, or we have some swaps on Uniswap or some DeFi transaction, their logs are emitted, and these logs are basically mapped uh, to certain opcodes, uh, which are log 0 and from log 0 to log 4 by the compiler. And each log opcode has address, topics, and data. So topic is for searching or indexing the log. So in currently there are topic there are 432 bytes reserved for the topics, and they are used whenever some ETH get logs JSON RPC API is queried, and this looks for the index topics for the relevant logs. So, yeah, and so next the part which comes into the picture is Bloom filter, which is the current which is currently used by the get logs API to fetch the logs. So Bloom filter is 2048 bit mask, What it does is it sets 3 bits for each transaction in the header, uh, and whenever some log is fetched, these 3 bits are looked whether they are for some the topic, whether these 3 bits are set. If they are set, then transaction receipt is downloaded. But the problem with this approach is this can be false positive. I mean, the log might not be present, but it says that it's present. Okay, we'll see how it happens. Uh, so yeah, this is the problem. Uh, so what really happens is if there are two logs with the which are mapped to the same 3 bits, they result in conflict, and this sometimes results in false positive. Okay, so let's say if there are 100 transactions, then the false positive rate is currently 33%. Okay, uh, and if as the log data grows in size, it becomes more prone to the false positive, and it's impractical. It becomes impractical for light clients and more, their depths to process it. So here comes the EIP 7745 into the picture. So EIP 7745 proposes to replace Bloom filters with log in with index logging as SSE structures. So SSE structures are compact structures which basically which basically proposes that log entries will contain Merkle proofs as well, which will enable trustless and verifiable uh, data to be given for the log queries, right? And it also proposes the filter maps, which is two-dimensional sparse matrix. Uh, so this two-dimensional sparse matrix is basically reduces the conflict, and it sets 1 bit for each log entry, which helps clients to download the smaller size data, and it is easier for light clients and resource constraints device to process this data and rely on the data without trusting any trusted API gateway. So this API basically uh, addresses the current log inconsistencies, uh, and it is helpful for the light clients. So yeah, and the impact of this EIP implementation has recently been seen in the Geth. So Geth has implemented it, and there was some data which compared the block query range between Geth and Red, and it resulted that Geth was fetching the same data in milliseconds, while the other client was taking few seconds for that same block range data. So yeah. Uh, so yeah, these are the benefits. And next, Tamagana will present the next part.
I'll go next. Thanks so much for the introduction. Now, he has already said, there are basically two parts of this EIP. The one is the log parts, and the other is the SSA related parts. Um, I'll just present. Yeah. So under the SSA part, there are two basic parts. Removing the old transaction. Basically, when we migrate log to SSA, some of the receipts schema get changed, and this, when coupled with legacy transactions, will break backward compatibility. To solve this, we are introducing SSA native transactions and SSA receipts. These are in two EIPs, 6404 and 6466. This will help us in SSA transactions and SSA receipts. With also this, there is another transaction 7706, which adds call data its own gas, and this also says to change all of the three gas, the blob, the normal execution gas, and the call data gas to a singular type of changing, which is exponential, and also three vectors will keep in place of which are already there. And the second part is the SSZ harmonization. We are also going to change the withdrawals and the whole execution block to SSZ. So the only thing that remains in RLP will be the execution state. Over here 6465 will swap with the withdrawal routes with the SSZ, and the final, the bigger one that comes as a execution block, which will be 7804. By doing this, we will be getting a binary engine API, which will be something like which the beacon APIs are there, unlike the current engine API. So another pictogram to help this better will be this. Over here we'll be first starting. Oh yeah. Also there are the SSZ requirements. The SSZ requirements are already being fulfilled by our mentor Ethan. So we are not putting much work in that, and for the time being he has already given up some workarounds to start the work. First of all, we'll be starting off with the, like we said, this is we are parallelize the work. Vinith will be working on the 2D logs, and I'll be working on SSZ transaction and then SSZ receipts. So that is how basically we'll be doing it. Yeah, that's all from my side, and we are open to questions. Also, yeah, I forgot to add this. This was already implemented in Ethereum JS on an older version of the spec, but Ethereum JS has been deprecated. So yeah, that's also there. Hmm.
Okay, thank you guys. Very well. Awesome. If anyone has any comments, questions, thoughts. Yeah, so my only question would be like that there is this division of labor between you and Vinit, and you also work on another project, right? So I
Yeah,
wonder, like, how does this, because we strongly recommend focus only on single project in EPF. So I'm wondering, like, how do you see your role, responsibility division here? Like, how much scope is working on the SSZ, your part, versus Vinit? Like, what is the ratio there, or like how do you divide it time wise? Whether you first want to work on this and later focus on the other project, or yeah.
yeah. So basically, both of the projects are Fossil and Puret. For Puret, like I said, I'll be working on the SSZ part. Vinith will be starting on the 2D logs, which is the harder part for him, and for me, it's the 6404. I will have started working on this and Fossil parallelly. For Fossil, like me and Zcash are working. Zcash is looking after the P2P and the fork choice related changes, and I'll be looking into the engine and the validator changes. Some of the work has already been done by uh, Zcash, which is the P2P changes, and I will be almost my engine related changes are done, so I can maybe put up a peer in NimWeb 3 by the end of the week. So that is what I'm thinking, and like the final decision was because the speeds and stuff are going fine, so I decided I can work on both of them parallelly. And also, like I had a vacation, so some of the work I couldn't do, but like yeah, I do feel like it will be possible for me.
Okay, just something to be careful about. It's a big challenge. Okay, there's a question from Malik about what is the cost of this EAP. I'm not sure what do you mean by the cost, like a gas cost, or what if you guys have any answer?
Yeah, I also don't understand the what does he mean by cost.
Oh, okay. Um, we are not actually changing anything basically related to, let's say, the execution of stuff. We are changing for the logs. I am not very sure that we need an answer. But for the SSA part, we are just translating how the data format is, and it's not much of a computational memory headache from that side. But for logs, I think we need can go.
I think the log part will not be very costly for memory because it is aiming to reduce the amount of data which is being downloaded currently for logs, and it will reduce the log size for, I mean, data which is being downloaded, and it will add the Merkle proof to the data uh, uh, for the trustless behavior. So yeah, I mean, so computation wise, it will uh, basically help to reduce the computation on the client side. So it will help the light clients so that they won't have to rely on full nodes or trusted APIs for the computation of the logs, right? So yeah, I hope it answers.
The aim of this EIP to actually purify the data that comes from the RPC so that we don't actually need to trust somebody to give us the right data. So this is more related to the data validity or purifying the Ethereum data rather than computation or memory. I hope that answers your question, or do you have any follow-up questions?
Okay, thank you guys. I think we should move on because we are 40 minutes in on the basically second presentation now. Now let's try to get back to Odinson if you are now with us and ready.
Yeah, hello. Am
Yeah,
I audible?
cool. Yeah, please try to continue.
All right, sure.
So,
So I guess this is where I was cut off.
yeah, go ahead.
Okay. So as I was talking about the fixed size LRU cache implementation, so this with current implementation that stores around 32 beacon states that typically occupies around 500 MB. But during non-finality incidents, during stress events, this can exceed to 2 or 3 GB. Now that is unsustainable or like inappropriate for the solo stakers or validators who do not have those hardware specs to run this amount, like run the nodes with this amount of storage or disk space. Okay, so inefficient during non-finality. This implementation or design choice, while it is very simple, this currently time-based LRU cache implementation is simple and has not been any problematic till date, but it was during the non-finality incident because of this out-of-memory condition. So what happens is that during the Holsky incident, the peers were requesting for the non-finalized blocks as they were trying to sync their local view. And what Lighthouse does is that it executes the state lookups. For now, for finalized data, the block roots are stored as a slot root to block root mapping. But for unfinalized data, it is a little complicated because of certain reorgs or like it can conflict with the side chains with the main view of the chain. So, what is my project proposal? So, my proposal is to replace this currently fixed count LRU cache with memory aware LRU cache. How will it work? So, currently there are this 32 states implemented like that stores the cache in Lighthouse. But what we will do is that we will have a certain limit and we'll be storing the memory of this beacon state. Now, what would this help in? This would avoid crashes. So this dynamic cache can avoid out-of-memory conditions in a way that whenever the limit is passed, we will be evicting certain LRU states until the entire cache limit comes below this safe mark. Now we will also have the option to adjust the cache, like optionally adjusting the cache capacity based on the pressure or like conditions, like if it is a normal condition or in stress conditions, such as something that took place in the Holsky, Vector Holsky incident. So certain possible techniques can be used to replace this LRU cache with memory aware LRU cache.
Uh, did he cut off again? Did he get cut off again? I think so.
Yep. And here we go again. Hi. Okay, let's give him a minute. Otherwise, we have uh,
Next would
Odinson
be
is
me and
back. Yeah,
Abhikash. Next would
Oh,
be
I'm
me and
not
Abhikash.
sure what is happening
Odinson.
actually.
Yeah.
I'm not sure what is happening actually. My internet looks to be good, but it is just disconnecting.
Okay, let's give it one more try. And if you cannot make it, or I mean, this applies to everyone. If you guys cannot make the presentation for any reason, you can always make a recording. You can just use OBS to record your screen and do presentation locally, and then share a video in case you don't feel like doing it live or you cannot make it in these calls. So that's a fallback. But now, yeah, go ahead while your internet works.
Yeah. So why was I lastly before I got disconnected?
Yeah, this slide.
Okay. Yeah,
Yeah,
so some
the
possible technical
recording
challenges.
slide.
One of them would be like measuring the actual memory for the beacon state, because it has different structures such as vectors, hash maps, arcs, and accounting the actual heap usage for this would be a little difficult, and like we'll be figuring it out. But one of the main challenges that even Mario was talking about with while I was sharing my project proposal with him was like mimicking this condition to check how the implementation has worked. That is like how we can create a scenario for this whole scale incident or like a non-finality incident where this actual memory, like memory based um, caching would actually be helpful instead of the count based. Another is like currently, as it is a simple LRU time based LRU caching technique that is used by Lighthouse, from this to migrating to a memory based, this can impact performance, but this would be checked upon the implementation as it like progresses and with time. Some resources that I would like to share is Michael Sproul's Lighthouse Architectures video, the Picta-Holsky incident by Sigma Prime. That is a blog written by Ethan. Um, Two issues related to this exact project proposal and how LRU cache is implemented by Lighthouse. This was my project proposal. Thank you. With a little bit of hectic.
Awesome, thank you. It's in three parts, but we get
Yeah,
it.
my
Yeah,
bad.
thank you. Yeah, and I also posted some review to your project proposal in the repo. Thanks for submitting that. Yeah, I think it's a good scope and a useful feature. I just think the biggest challenge there is testing, because right now we don't have a network where we could simulate such a big non-finality with such a big state, right? Like we cannot just
Right.
take Hoodie or some big testnet or mainnet or something to simulate this. So there might be some efforts to do this later in coming months, and I will let you know if DevOps have some better tooling or PandaOps have some better tooling for this. But right now we are kind of missing this. So yeah.
Sure, like
Any,
that would be great. And I also have a talk with Michael and Daplan regarding this as well.
yeah, cool. Yeah. Any other thoughts, questions here? Otherwise, so looking at the last person from last week, we're still in the last week's call here. Vedant, didn't present. Yeah,
Hello, am I audible?
yeah. Go ahead.
Yeah, let me share my screen. So I think it is visible for everyone.
Yeah. All good.
Yeah, yeah. So I'm Vedant Asati. So I'm CSE student at IIT Dhanbad, basically India. So my project is backfill implementation for Lodestar. So this is the PR for EPF project that Phil has made on Lodestar GitHub. Yeah. So yeah, so I will start with some background. Actually, so what is weak subjectivity? I think like most of us are like very aware about what is weak subjectivity, but yeah, still I would like revisit some things. Weak subjectivity, so it is a concept specific to POI systems to address how new nodes can safely join the network and synchronize with the correct blockchain history. So in POW systems, there is this computational overhead that any attacker needs to have to attack the system. But in POS systems, there is like not that technical overhead for attacking the system, and like there have been research about certain attacks, specifically I would say like long range attacks when when a validator who when one third of validators can leave the system, and when their stake is returned, and there is like a very long time, and the nodes which get offline for this long time, and when they try to reconnect to the network, when they try to catch up with the network, so these one third nodes, if they are attacking nodes, so they can somehow manipulate the node to believe in wrong chain. So this is called like long range attacks. So basically for this, uh, like there is specifically a like sync mechanism was developed, like, so it is checkpoint sync. Meanwhile, I will like also scroll about also like brief about other syncing methods. So like there are many syncing methods which are like currently implemented in the clients. Specifically, I will tell about like the beacon clients. So yeah, so like first is historical sync. It is the like normal sync. It involves processing all blocks from genesis or from a specified starting point to the current block. So this is most comprehensive sync method, and yeah, it is very resource intensive, and like we need to sync from the genesis. So as I mentioned, like the long range attack, so it is prone to those long range attacks, and it is currently not the recommended method. Current recommended method is the checkpoint sync. So it is faster, and also it is safer. So what is checkpoint sync? So this is also called state sync. So checkpoint sync, basically it involves syncing to a recent finalized checkpoint, allowing the node to quickly join the network and participate in consensus activities. So basically we get a recent finalized state from some trusted node. So basically this is done currently by providing checkpoint sync URLs. So the node gets the state from there, and after that finalized state, it can move forward and like sync to the head of the chain. So like the forward syncing part after the finalized checkpoint, it is like called range sync. So we can like a request for specific blocks in the network, and like we will get it. Like range sync is like also for if we want to fill up some holes in the our like previous blocks or so. Yeah. Then comes backfill sync. So what exactly is backfill sync? When we do checkpoint sync, we get state for finalized checkpoint, and like then we do forward sync. So we have the blocks from finalized checkpoint to the current head, and like we can continue with like participating in the network. Validators can also start performing their duties. So like uh, we are catching up with the chain, but we don't have the previous blocks. So for getting those previous blocks, we need to do backfill sync. So we do this like starting from the checkpoint state, we request going backwards blocks, all the blocks up to there is this there is this minimum epochs for block requests. So it is like around 5 months period. So basically we need to backsync up to almost 5 months of blocks, so that like we can participate in the network, and like we can be able to fulfill beacon blocks by range requests from the network, and like be more useful to the network. And this issue was also like the lodestar nodes faced this issue when there was non-finality in the Spectra testing in the test nets. So yeah, so like this is basically the process basically after node starts, and after week subjectivity duration, it does a checkpoint sync from a trusted node, and after that we do backfill sync. So yeah, we get the blocks backwards, and yeah, it can alternatively be done up to Genesis. This is for the archival nodes or like specific use cases, testing and all. So generally, clients do provide additional flags if you want to like force this up to Genesis. Yeah, like talking about Lighthouse, there are also like certain flags you can like limit backfill sync if it is taking too much of RAM, or if you want to like force it to be like done very fastly, then you can like also provide it more RAM so that it can be done fast, so that you can serve these requests. And yeah, if you don't serve these requests as per the spec, you will be like your score will be reduced and you might get disconnected and maybe blacklisted. Yeah, so this was for the blocks, and similarly we need to backfill the blobs. So currently, like for the blobs, all nodes are like expected to keep the blobs data, but with PRDAS, it is going to change. PRDAS custody groups, so the blobs will be divided for different nodes, like the duties will be divided, which nodes will store that. So that is like more of peer dash specific things. So basically from the spec I got this: when syncing, a node must backfill columns from all of its custody group. So basically whatever like a node is required to serve, so it needs to serve those blocks, otherwise it will be descored and like all those consequences. So backfilling blobs is currently implemented in most of the clients. Yeah, in Teku, I think in Lighthouse, in Nimbus, but it was in the Lodestar, but not currently enabled in the Lodestar. I will come to that. But yeah, but backfilling blobs and like this PRDS integrations, these are mostly work in progress. I inquired about this in the Discord of like Lighthouse, and like I also like saw on the GitHub and all, like it is not currently implemented in the clients, so like this will be new thing for me to look on. Yeah. So previous work. So in Lodestar, they already had backfill implementation, but I then inquired about it and then like discussed with the code devs. Then I got to know like it was causing some performance issues long back, so it was disabled. It is currently still there, and I explored it, and yeah, I was trying to grasp it. And yeah, so like what we want to do next. So as per the devs, they are like planning to write design efficient algorithm for backfill. Like we need to re-implement backfilling from first principle,
Gonna
so
be
that
recording over time if you can just take it faster. Yeah, like
yeah,
that.
2 more minutes. Yeah. Yeah, so like I will come directly to what the main things. Yeah, so we need to like re-implement it from first principles. And previously there were no worker threads in Lodestar, as like it is a TypeScript client, so like there are many issues with JavaScript, like it is high level language. So like we want to re-implement it from the scratch, and then utilize worker threads so that we can not block the main loop, main thread. Then testing, and yeah, we need to release it in Lodestar v2.0. So this is my like tentative timeline. Currently, I'm in this stage. I'm working with them. I'm getting review on like the algorithm, what we will continue with. So like week 1 to 5. Currently, I think week 4 5 time. It's so I'm basically on the algorithm design. I'm like working on the proposal, and I will soon share my proposal. Then I believe 6 to 9 I will implement backfilling. Then for blobs, and then yeah, 3 weeks for testing fixes and optimizations. I think this project will be little slightly lesser duration than actual, because as I said, for Lodestar V2.2 release, they are planning in 2 to 3 months, so we need to do all of this testing and all before that. Yeah. So final deliverable is create implementation, testing release. Yeah, and then present my work at DevConnect. So there are no official mentors currently, but I would like confirm with the team. People are helpful, and I'm discussing with them. Yeah, these are my resources. Yeah. So if yeah, that was it. If you have any questions specifically, if you want like more info, you can see the resources, and I might also add some more resources here. My most of the updates are in like EPF updates, so I didn't repeat all those things here.
Okay, thank you so much. What about, yeah, do we have any questions, any thoughts about the backfill in Lodestar? Thank you so much, Vedant. Okay, we have 90 minutes for this call, so we have 30 more minutes. But again, please make sure to keep your presentations between 5 to 10 minutes. Everybody now has been longer than that, and we don't have enough room for more people. So please be conscious about your fellows, and you don't need to spend too much time explaining the basics, the details about like what is clients and sync, but focus on the actual meat of your project. Omanikin, if you are ready, you would be the next to present.
Yeah, sure, I can present.
Okay, awesome. Please go ahead. Yeah, great.
Is it visible?
Yes, all good.
Hello. Yeah. So, hello everyone. I'm on this side, and I'm working on a Grandine's project, which is ZK VMs for beacon chain snarkification. And this project is similar with Ream Client's project. Dimitris and Utsav have already presented, so I will not go much technical and will not take much time. And as we all know, Justin Drake announced the Beam chain proposal at DevCon 2024, and he also talked about Chinese narkification. Since then, validator clients are planning to integrate ZK VMs. So Grandine also started experimenting with ZK VM to enable snark proving of the beacon chain state transition function. And also recently we got an EF blog about shipping L1 ZK VM for real-time proving. So ZK VMs are in a competitive world. Okay, so the state transition function is a core of the beacon chain, and it takes two inputs, beacon state and beacon block, and it goes with a heavy computation and gives and provides us with the output that is a new beacon state. So because of this heavy computation, we are going to use a ZK VM. We should be doing this. We should be offloading this computation and providing us a zero knowledge proof, succinct zero knowledge proof that can be used to verify the validation of the state, and we can say if it is valid or invalid. And like zkVM is going to take two inputs like pre-state root and block, and it will be providing us with a post-state root, so that and proof, so that proof can be used to on-chain verification, that is the chain snarkification. Now Grandine is currently working on SP1 and RISC-0 zkVMs that are said to be most mature and production ready zkVMs, which currently show promise for networks with tens of thousands of validators. Our future work would be to scale this work to support larger validator sets and explore zkVMs like OpenVM and Zisk that offer continuation supports. Okay, so this is Grandine architecture. You can see in the repo. Uh, they have a state transition, slot processing, and epoch processing, block processing. different files for different things, and we have also BLS and SSD, BLS signatures, SSD serialization. This is a state transition function architecture. Basically, state transition function is a wrapper of process slots and custom process block. And this process slots contains process slot processing, and the epoch processing. So this epoch process epoch and block custom process block, these two functions are very computationally heavy. So we'll be mainly implementing on these two. Current focus for the project will be to explore OpenVM and Zisk for potential integration. We'll be looking into the architecture and see what they uh, give us about continuation. And we are waiting currently for SP1 and Risk Zero and repos integration reports to be get public, so that we can resume work. Currently they are private, and I talked with Solius, and he said that we can start get familiar with OpenVM and Zix till that time. In the meantime, we'll also be looking in the Ring clients repos. They have already integrated SQL and Zero, and their repos are public. So yeah, we'll be looking that also. Okay, thank you. That's from my side. If you have any doubt, I would love to discuss.
Yeah, perfect. Thank you so much. Yeah, great timing. Awesome. Any questions? Any ZK curious people? Questions, comments? Okay. And because I don't see Onikin in this call, we would continue with Vukasin, or excuse me, no, he's not available today. I'm sorry. That's but outdated. Vukasin, yeah, raise your client on the fossil then.
Uh,
Yeah, Tamagna, are you ready?
yeah, I am ready, but I don't think Zcash will be joining, so I'll be presenting for both of us.
That's all
Um,
right.
Hi, I'm Tamagna. So I have also chosen Nimbus for in Nimbus CL Fossil. Our mentor will be Agnish Ghosh. Uh, what is Fossil? Well, basically, Fossil gets back credible neutrality for the chain. We introduced IL committee, and they give out IL inclusion lists, and these inclusion lists transactions must be included in the next block. So I'll be not going into much detail because everybody knows about it. For the proposed timeline, this is three parts. For the first part, we'll be working on the code changes. We have divided two ways: the P2P changes and the fork choice changes, which will be handled by Zcash, and I'll be doing the engine and validator changes. For the second phase, we will be going into the interop testing with the Prism CL and get and determine CL to check if Nimbus CL can consume and is able to process the fossil enabled blocks. And in the final, we'll be deploying it to the local testnet that is being run by Jihun, which has a lot of the clients participating in it, and continuously monitor our implementation and also help in some other Nimbus efforts for fossil. And then if we have time, we might also check out things like 6 second fossil plus EPBS interop for Nimbus and stuff like that. So for the updates from us, the P2P changes, the PR has been already put up by Zcash, and it has already received some feedback from the team, and I'll be doing the engine changes by this week. Yeah, that's all from our side, and we also had we are on schedule for this project. So yeah, nothing much. Any questions or anything related, if anybody would like to ask?
Yeah, okay, thank you. Yeah, that's pretty easy. Yeah, so I mean, yeah, I asked about this before, but maybe just reiterate, like, which project do you see has a bigger scope for your own work? Like, where are you going to pay more attention, or will have to spend more time? What do you see as the bigger challenge?
The bigger challenge will be Pureit, because for fossil we have already mapped out the work, and like we already know where the changes are going, which changes will be going, and how fast. We already have a timeline. But for Pureit, I'll need to sit with the EL code base and like stuff like that. So that is what also like for Pureit, I think some of the things might change, some of the things may be discarded and rewritten. So I see that as the bigger challenge. So
Yeah, makes sense. Thank you. Anyone else? Otherwise, we can move on. And there is developer Uchi.
Yeah. Hey guys, I'll share my screen right now.
Mhm. Yeah, looking good.
All right. So yeah, my name is Ojai. I have a background in computer engineering and for blockchain engineering. So my project for the EPF called Success focused on ZK EVMs and its scalability for Ethereum. So I'm working hand in hand with the protocol team at the Ethereum Foundation, the ZK EVM team at the Ethereum Foundation, and yeah, that's it. I'll just dive into what I'm working at right now and what I'll be working on for a while. So my project is kind of different because my tax comes in as some research questions pop up. So these are the questions I've been given so far, and some of them is almost done, some of them is heavily in progress, and more would be coming in as time goes on. So my core research areas right now is on hybrid EVM environment. So an EVM environment that can run EVM contracts and RIX5 contract. So this is tailored to the possible proposal for um, and a RIX5, enshrining RIX5 as the execution environment or sandbox for the Ethereum blockchain. So the research is aimed to having a POC and giving us data on if this is a good idea, if this is good for compute, if this is good for ZK, if this is good for statelessness, if this is good for light clients, and all those questions would be answered by this research. So the next question I have on my table is Zix trace generation. So the team Zix, so the spin-off of Polygon. So they did something unique a few weeks ago where they made their trace generation process. Trace generation is a stage in ZK proof generation. So they make their trace generation process as fast as 1.5 gigahertz per second, which can go up to 2 gigahertz per second. And that's about 10x state of the art. So my research endeavor was to see if this can be generalized over various ZKVM in the ecosystem, having also different ISAs. So the next is Linux API and system call for ZKVMs. So currently, if you are confident with ZKVMs these days, most of the guest program is written in Rust, and there is a reason why that is so. So Rust have a good abstraction for the STD and the targets machine or virtual machine that's the Rust program is being run at. So you can easily swap out the runtime environment using a custom target built with LLVM backend or something. So in other language, this is tightly coupled. So for if I'm building with get and I compile it to RIX5, so what I get is RIX5 Linux or RIX5 whatever OS I'm going to be running this on. So that poses a problem because if we transition to snackifying the execution layer fully, all the work we've put into client diversification, having clients of different programming languages, would be a waste. So this research endeavor is to try to expand. Is a proposal to highlight things we need to do to make ZKVMs, make ZKVMs be able to run, let's say, guest program as it can run Reds as its guest program. So I've pretty much talked about all this. So you could check on the side, but this everything I've talked about. So the research one, EVM environment for EVM plus with 5 execution. So this is something I've been working on before the program. So after joining the program, I meant to ask I finish this and also give a report as it's an item that the research team has on their tickets. So the report for this, that's the complete report, things like how this is going to pose to computation, how this is going to pose to things like an ERC20 token transfer, how many cycles on an EVM, how many cycles on RIX 5 sandbox. So more questions is also documented to be answered by this report, and this should be ready on the 15th. So the next one, I'm done with this already, and the report have been released. So the end goal of this is it's possible to generalize the Zix trace generation technique, but um, it's fairly complicated, and it would have to force ZKVMs to redesign some certain component of their proof system, which many ZKVM would not like to do that. For one of the parts is to have everybody use the Zix ISA, and not everybody's going to do that. So the report is also published public. So if you want to check it out, you can check it out. So the last one, which is currently in progress, is highlighting all the syscalls and Linux APIs that ZKVM needs to support to be able to run Rust, not just Rust, to be able to run things like gets or Nethermind execution client written in C Sharp, compiled down to X5. So guest programs of those nature um, wants the ZKVM to be able to support it also. So when we go full on snapification of the execution client, we don't just have guest program written for ret, and we can also like have to enjoy this client diversification even during snapification. So I'm done with the ret side, currently working on the get side. So we'll be done with everything by the 30th. And yeah, that's the second. Yeah, yeah, that's the so for my deliverables for this there's a proof of concept which is done, a research which is done, I did a report which would be done. So my mentor is Kev from the EF, and this is me, David Uche. Thank you very much.
Thank you, developer. Great. Yeah. Do you have any questions? Anyone? Any comments?
Yeah, one question. Like you said, for the we will be needing to the Linux APIs and stuff like that. So, are there any plans to, let's say, support direct LLVM backend joins or something like that? Because that would be helpful. Like also, we were working for with Zix for this because most of them support Rust. So uh, we needed to link the generated file back up for us to run the code for Zeal. So like, how does it look for a generalized solution? Look for all of the clients using ZK and stuff like that.
Yeah, so I looked into that, and it feels like a big challenge because it means um, we can't just have one LLVM backend for all the ZKVMs. So all the ZKVMs have various things like pre-compiles and various custom related code injection they inject into their guest program to help them prove faster. So we can't just have one LLVM backend for all the ZK VMs. So what we are looking to do is to like see if we could have a standardized um, um, some standardized documents that all these ZK VMs will have to like commit to. So we can now still have more like a roadmap to having something general where um, any programming language that has an LLVM IR, which almost all programming languages today do have, we could easily just combine it with the particular backend, and we can have a provable guest program. But that's still long, long, long away from the pipeline.
Okay, yeah, makes sense. Thank you. Thank you. We have some research, and now for the last one, it's Jay on the Rim client. We get you here.
Yeah, Mario. Fine.
Awesome. Go
Uh,
ahead.
right. So you guys can see my screen.
Yeah, so good. Go ahead.
So yeah, I'll be working on Ream. So what is Ream? Ream is a Rust-based validator client for the Beam chain. So before the project, this is about me. I'm Jay. I'm a blockchain developer from India, and I've joined permissionless. So what is Beam chain? So I mean, just quick introduction is Beam chain is the redesigned consensus layer of Ethereum beacon chain, which is proposed by Justin Drake at DevCon. So the reason behind this proposal is right now the roadmap of Ethereum is a decade long, and before uh, only once all these updates are completed, we can finally bring the Ethereum into the maintenance mode. And also the current implementation of Ethereum, the cryptography followed is not quantum resilient, which means since we have the quantum chips being developed, the development of quantum chips is getting multiplied day by day, and the progress is exponential. So there, it does poses a significant threat to the Ethereum resilience to its cryptography hashing and all. So and also right now we also have another problem with the decentralization, with the validators being centralized, like only the centralized people with 32 ETH uh, organizations, the big organizations are running more validators, which is in a way making Ethereum centralized day by day. So these are the problems that the Beam chain is supposed to solve by reducing or the other methods of uh, amount for the staking, and also making the strain transition function quantum post quantum resilient by using the ZK proofs or the approach. The main goal is to use the ZK proofs, which is the best option we have right now. So we can find the information about the Beam chain and the roadmap of it in this link. So this is the Beam chain. And when it comes to Ream is a high performance Beam consensus client that is written in Rust. So there are around 15 teams that are trying to implement the Beam client, and Ream is one of those. So right now, the Beam chain roadmap is not yet like the even though the roadmap is finalized, the technical specifications, the end goals are not yet completely fulfilled. So it's still under progress. So according to the roadmap, by the quarter four, or by the end of this 2025, the year 2025, we should have the technical specs written, and like from the proposal what we have so far, the beam chain should be backward compatible with the beacon chain. That's what we have right now. So it's more like a redesign rather than a uh, total new implementation. So it should be backward compatible, and it should be using most of the current endpoints that we have at the moment, which includes the validator management, the attestations, etc., the sync committees and all. So I'll be working on the validator endpoints and possibly the beacon chain endpoints as well on the Ream client. So the specifications of the beam chain and other things can be found here. And mm, I think one of the leads for this meme Ream client is Colby. So I'll be taking his help. And since it's already implementing the existing parts of the Ethereum consensus right now, there shouldn't be any problem apart from the knowledge gaps. So these are the at the moment the Ream client is focused on implementing the Electra hard fork of the Ethereum rather than the latest update. So yeah, for that we can find all the resources here that we can use, and also since uh, consensus layer are a deep knowledge, like deep part of the like deep subject, I'll be using the Lighthouse implementation as well for the reference. And yeah, these are all the resources where we can find more about the current consensus specs. And yeah, that's all from my side about this project. uh, Hello.
Yep, thank you for the presentation. Not sure what happened to Mario, but um, any questions or comments for that presentation?
Yes.
All right.
And,
Oh, you're back.
second. Yeah, thanks, George. Yeah, thank you guys. And yeah. Okay, I think that was enough. It was all for today. Sorry, I just lost last minute. I lost the connection there. I had to reconnect. Um, so yeah, Jay, thank you so much. Unless there are some more questions or comments, or anybody wants to discuss, ask something. Otherwise, we will wrap it up here. Um, and we'll have another office hours presentations next week because we have still a couple of people who didn't make it. Okay. Okay, well, very well. So thank you so much, everyone who presented today. It was really great. Many great projects out there. I'm excited to see that, and I'll see you again next week for more presentations. Then I'll see you on Monday on the stand up. Yeah.
Bye. Thanks.
Thanks, everyone.